Welcome to another video. Uh, this question is appeared in CSIR net June 2012. The question is from vector space. The question is nothing but we have to calculate the dimension of the vector space of all symmetric matrix A AIJK of n cross n with real entries and A 110 and trace is 0. We know that the dimension of symmetric matrix is equal to n into n plus 1 upon 2 for n cross n matrix, and we have to actually calculate the dimension of the matrix symmetric matrices where A11 is equal to 0 and trace 0. That means there are two linearly independent constants. Then the dimension of A is simply nothing but the dimension of symmetric matrix and minus number of independent constants. That means n into n plus 1 upon 2 minus 2 is equal to n squared plus n minus 4 upon 2. A is the right answer. Again I am saying what I have done here. We have to calculate the symmetric dimension of the all symmetric matrices with real entries, and A11 is equal to 0 and trace is equal to 0. Simply the dimension of symmetric matrix I have already discussed in the last video, where the dimension of symmetric matrices of n cross n is n into n plus 1 by 2, and dimension of A simply nothing but dimension of symmetric matrix minus number of linearly independent constant. That means n square plus n minus 4 upon 2. Okay, let's move to the second question. Same question, we have to actually calculate number of distinct subspaces. Here V be a three-dimensional vector space over the field F3. F3 means Z over Z3, that means of 3 element. The number of distinct one-dimensional subspace of V. If dimension of V is equal to n and number of element in the field is P, then the k dimensional subspace of V is simply nothing but P power n minus 1 into P power n minus P up to P power n minus P power k minus 1 upon P power k minus 1 P power k minus P up to P power k minus P power k minus 1. This is the formula for k dimensional vector space of V, where dimension of P is n and dimension and the element of F is P. Then after we have to calculate here n is 3 and k is 1 and P is 3. That means dimension of one-dimensional subspace of the one-dimensional subspace of V is equal to 3 power 3 minus 1 3 power 3 minus 1 divided by 3 minus 1. That means 26 upon 2, that means 13 is the right answer. This is the formula for k dimensional subspace of V, number of distinct k dimensional subspace of V. Here k is 1, that's why we are taking the one factor, that is 3 power 3 minus 1, these factors. Then 3 power 1 minus 1, that is 2, 26 by 2 about 13. So the number of distinct one-dimensional subspace of V is 13. Okay, next day I will upload the next video on previous year question paper of CSIR net mathematics. Thank you.